Where did the universe's extra gravity and that constant hiss of cosmic background noise really come from? In the energy filament theory, both point to the same culprit: swarms of unstable particles. Tiny short-lived structures in the energy sea whose collective behavior is what we have been calling dark matter. Start from the puzzle you've heard 100 times: galaxies spin so fast that, if we only count visible stars and gas, they ought to fly apart, yet they don't. Galaxy clusters hang together more tightly than their visible mass allows. On top of that, every telescope, from radio to microwave to high energy, sees a persistent background fuzz, like an old TV that never quite goes silent. Standard physics patches this by adding dark matter, a whole new kind of invisible stuff that adds pull but refuses to show up in detectors. For decades we have dug mines, cooled huge tanks and built exquisitely sensitive sensors. And still no confirmed dark matter particle has been caught. It works as a bookkeeping fix, but it's still a missing actor. Now swap the picture. Imagine the universe as a restless energy ocean. Its surface is full of tiny curls, ripples and tugs. At every moment, countless minutes of filament loops are being twisted up out of that sea and just as quickly smashed back down. They appear, live for a blink and dissolve. These are generalized unstable particles. Each individual one is weak and short-lived, but there are so many that their combined effect is huge. They leave two different fingerprints. The first fingerprint is stamped while they are alive. Every time one of these short-lived loops is formed, it pulls the nearby energy sea slightly tighter, like pinching a rubber sheet for an instant. One pinch does nothing on cosmic scales. But when an enormous number of such particles are constantly being created in some regions, those tiny tightenings add up statistically into a persistent gravitational floor. A shallow but real tension base underneath everything. Galaxies that should drift apart are actually sitting on this floor, and their flat rotation curves are telling you you're standing on that hidden platform. It is as if you felt extra weight in the floorboards because a rain of invisible raindrops is tapping them faster than they can fully relax. The second fingerprint appears when these particles die. As each little loop unravels and its structure is dumped back into the sea, it sends out a small disturbance, like snapping open a knotted string and letting it shiver and lie flat. One such death ripple fades quickly, but the universe hosts an absurd number of them, so they broke up into a fine, almost uniform noise carpet of tiny waves everywhere. The diffuse radiation and radio background you always see, the baseline hisses under every deep observation, becomes, in this language, not a mysterious leftover, but the combined aftershock of billions upon billions of unstable particles ending their lives and shaking the sea. So one class of objects with two phases of behavior explains both the extra gravity and the persistent background noise. There is also a sharp difference in how many assumptions you need. Dark matter, as usually told, demands an entirely new category of matter that has never been directly seen, invented just to fix the gravity ledger. Unstable particles are the opposite. Laboratories have already discovered hundreds of short-lived species in collider experiments, with tracks and decay signatures recorded in detail. This theory simply extends that already real populations to cosmic scales and gives them a bigger job description. To get a feel for how little is required, one estimate says that on average, about 2.18 grams of generalized unstable particles per trillion cubic kilometers of space would be enough to generate the observed extra gravity. A trillion cubic kilometers is an almost absurd volume, and a couple of grams inside it is practically nothing. Yet constant creation and decay over time can still build the floor and the noise. By Occam's razor, when one missing piece demands an entirely new invisible substance, and another uses entities you already know exist and, at the same time, explains both the gravitational anomalies and the cosmic noise, the second option is far more economical. Under that lens, dark matter stops looking like a new kind of stuff and starts looking like a misread label on the life cycle of unstable particles. Tap follow, share it on New Physics, Clear Universe.